Here we have a SAT math problem. Okay, let's go to the question. A quadratic function models the height in feet of an object above the ground in terms of time in seconds after the object is launched. The model indicates the object launched from the ground, that is 0 feet, and reaches its maximum height of 576 feet above the ground 12 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 16 feet after being launched? Okay, let me draw an XY plane. 1 second. Okay, here I've drawn XY plane. Let me take x-axis over here and y-axis over here and take the time in seconds on x-axis. Let me write the stuff over here. And height on the y-axis, that is in feet. Okay, according to the given information, the object launched from the ground, that is in the height of 0 feet. And also when the object is launched, the time is 0. So that is the object is launched from the origin in the xy plane, 0, 0. That is time is 0 seconds and the height is 0 feet. And we know that whenever an object is launched above the ground, the path of the object will be a parabola like this. Okay, here we get a vertical parabola which opens down. So the object travels towards upward and reaches a maximum height over here. Then it starts coming down. And according to the information, the maximum height reached by the object is 576 feet at the time of 12 seconds. And we have taken the time on x-axis. So we have to consider this 12 as x-coordinate and this 576 feet height as y-coordinate at the vertex. Okay, let me write over here 12, 576. Okay, here we have the parabola, that is vertical parabola, which opens down. Using the vertex, we can write the quadratic function which represents the path of the object. Once we get the quadratic function in which we can plug in this 16 for x and we can get the value of y, which gives the height of the object the time 16 seconds after being launched. Okay, now let me write the quadratic function in vertex form, that is y equals to a times x negative h the whole square. Positive k. We know that h comma k is the vertex of the parabola. Here for h comma k we have 12 comma 576. Let me plug in this 12 for h and 576 for k in this function. Then I'm getting y equals to a times x negative 12 the whole square, positive 576. Still, the quadratic function which models the path of the object is not complete because there is an unknown constant a over here. To get the value of this unknown constant, we have to use one of the points on the parabola. Apart from the vertex, we know that the point 0, 0 on the parabola. Let's plug in this point into this quadratic function to get the value of a. That is, we have to plug in this x coordinate 0 for x over here and y coordinate 0 for y over here. Then I'm getting 0 equals to a times 0 negative 12 is negative 12 the whole square, positive 576, and 0 equals to negative 12 the whole square is 144. There is 144 a positive 576. When I subtract 576 from both sides, I'm getting negative 576 equals to 144 a. When I divide both sides by 144, I'm getting a negative 4 on the left side, and the right side we get a. Okay, here I got the value of a. Okay, let me plug in the value of a into this quadratic function over here. Then we get y equals to negative 4 times x negative 12 the whole square, positive 576. Here the value of a is negative. This is a leading coefficient. The leading coefficient is negative because the parabola opens down. Okay, now the quadratic function which models the height in feet of the object over here is complete. Our aim is to find the height in feet of the object above the ground 16 seconds after being launched. That is, we have to plug in this 16 for x over here and find the value of y in this quadratic function. Okay, now let me plug in 16 for x. Then we get y equals to negative 4 times 16 negative 12 the whole square, positive 576. Let me continue over here. Y equals to negative 4 times 16 negative 12 is 4. That is 4 square, positive 576. Then we get y equals to negative 4 times the value of 4 square is 16, positive 576. And y equals to negative 4 times 16 is negative 64, positive 576, and y equals to 512. Okay, when the time is 16 seconds, that is 16 seconds after the object is launched, the height reached by the object in feet is 512. We find 512 in answer choice D. The correct answer choice for this question is D.